All right, we're going to look at some problems from section 10.2. We're calling these the enrichment problems. They're kind of stretching a little bit, but there's certainly a lot of similarity to some things we've done, especially with, like, say, flipping a coin and looking at probability trees. This first scenario talks about stock increasing. It says the probability that a stock increases in value on Monday is 60%. When the stock increases in value on Monday, the probability that it increases is 80% on Tuesday. If the stock does not increase on Monday, only a 40% chance it will increase on Tuesday. Okay, first question is to draw a probability tree. Okay, so here's Monday. So we have a 0.6 to increase, 0.4 to not, right? This is going to be the increase side. This will be, I shouldn't say decrease because it could stay the same. So that would be the not increase. So then next one is Tuesday. If the stock increases on Tuesday, then there's an 80% chance it will do so again. So we'd have 0.8. That means there's a 0.2 chance it does not. And then if it does not increase on Monday, 40% chance it will increase on Tuesday. So again, here's the increase. Here's the not increase. So notice, very similar to what we did with our coins, except we would have 1/2 all the way down. So 0.6 times 0.8, there is the increase Monday, Tuesday. Increase Monday, not Tuesday, multiplying again 0.12. Not increase Monday, increase Tuesday. Not increase, not increase. And there's all of our scenarios and probabilities. Now it says, what is the probability the stock increases on both Monday and Tuesday? So there's the Monday, Tuesday. So that would be 0.48. Then the next question, what is the probability the stock did not increase on Monday if it did increase on Tuesday? So that's the probability not increase Monday given did increase Tuesday. So we have a conditional probability. So where do we find the did increase Tuesday? Well, there's a did increase Tuesday. There's a did increase Tuesday. And within that, where is the did not increase Monday? Well, there's the did not increase Monday and the increase Tuesday. So go to our calculator. So 0.16, divided by the 0.48 plus the 0.16. And that would be 0.25 or 25% chance. Okay, next question. It says a company job screens applicants for illegal drug use at a certain stage in the hiring process. The specific test they use has a false positive rate of 2% and a false negative rate of 1%. Suppose that 95%, suppose that 5% of all their applicants are actually using illegal drugs, and we randomly select an applicant. Given that the applicant tests positive, there's the given, what's the probability they're actually on drugs? Okay, so let's create a probability tree again. So we know 5% are actually using. So again, we'll put our using here. So 5% or 0.05, that means 95% are not. Now, we're going to drug test. So there's a false positive of 2%. So that means that those who are false positive means you're not using, but you're tested as positive. So here's the group that's not using. So the 0.02 would test positive. That would be false. That means there's 0.98 that test negative and are not using. Now we have a false negative rate of 1%. So that means that you're using, but it tests negative. Well, here's the using. So a little negative there, right? So the negatives, that's 0.01. So that means that the positives who are using are 0.99. So again, using test positive, using test negative. There's that false negative, the 0.01. Not using, but test positive, that's the 2%. Not using and test negative. So again, down at the bottom, we would multiply to get our number. So we have 0.0495. We have 0.0005, 0.019, and 0.931. Okay. So now, what's the probability that, they've given the applicant test positive. Okay, so where do we find the test positive? It's the 0.0495 and the 0.019, those tested positive. Now, what is the probability they actually are on drugs? So where do we find the positive and on drugs? That's this number. So that's 0.0495. And going back to our calculator, 0.0495 divided by 0.0495 plus 0.019. And we end up with about 72.26%. Okay, let's look at this another way. I'm going to get another piece of paper here. So one other thing you could do if you're having some difficulty is to create a sample space, okay? So let's say you put 1,000 people in your sample space, and we look at the same question. Okay, so 5%, that means 50 people are using drugs, right? Because remember, back on this question, 5% of the applicants are actually using illegal drugs. Okay, so that means there's 50, and that means 950 are not. Okay, now it says there's a false positive rate of 2%. So that means of those that are negative, or not using rather, 950, that means 2% of those, so times 0.02, that means 19 will test positive. So that means 950 minus 19, that means 931 people who are not using drugs will also test negative. Okay, so now we go to the 50, there's a 1% false negative. So that means that 1% of the 50, so 50 times 0.01, that means, oh, my numbers, you're right. I should have gone to 10,000 because that's not going to, we can't have half of a person. All right, so let's make this 10,000. My mistake there, not looking far enough ahead. So that just adds a 0 to all those numbers. So again, just to confirm, right, if we took 500 times the 0.01, that would get us 5 people. That means 495 people who are using drugs will test negative. Okay. I think I actually have those switched. Yeah, that's my mistake, right? If we go back there, it should be the other way around, right? Because it's only a 1% false negative and the negatives are over here, right? Because that was negative and positive, right? Go back to there, negative and positive. So negative and positive, that should be 495, and that's 5. Okay, so looking at the same question, given that the applicant tests positive, so where are the positives? So we have 495, right, and 190. What's the probability they are actually on drugs? So how many test positive that are on drugs? There's the 495. So if we use our calculator again, 495 divided by 495 plus 190, and notice we get that same approximately 72.26%. So it's one of the things that you can always do if you're looking at a problem and you're having some difficulty with just looking at the percentages and or probabilities, create a sample space. And so in this case, creating a sample space of 10,000 job applicants And then you can use the percentages and you can actually look at this as bodies, and that may be a big help. So I hope that helps, and we'll see you soon.